Welcome to the TC Dojo from Single Sourcing Solutions. The TC Dojo is a TechCom community that is driven by you. Tell us what you want to learn. You choose the topics, and we find the experts. In the TC Dojo open session today, we have Kirk St. Amant, Professor and Eunice C. Williamson Endowed Chair for Technical Communication at Louisiana Tech. He is also an adjunct professor of International Health and Medical Communication with the University of Limerick in Ireland. He has published dozens of peer-reviewed research articles, he's an STC Fellow, and he's the co-author of Thinking Globally, Composing Locally, Rethinking Online Writing in the Age of the Global Internet. He's also one of the community leaders involved with launching the medical writing STC SIG. In the last few years, more and more technical communicators have become more interested in usability and user experience, and this is one of the focus areas of his academic research and consulting work. There's a lot more to know about him. He's an extremely active researcher who also encourages practitioners to pair up with academics in order to advance our entire profession. He was in the dojo last year, and everyone said it was one of the best we've ever had, so we are especially grateful he could come back today. I guarantee you'll enjoy his session.
Liz, thank you for this opportunity and for your patience with me getting this set up, and thank you all to everybody who's attended today. What I'd like to do today is quickly go through some factors about cognition, or how the mind processes information, and look at how they affect aspects of visual design and influence usability. I'll be going through quite a bit of material, and if you have questions as they come along, please hold them till the end, and I'll try to connect things back as I move through the process, but hopefully be able to address things toward the end as well. So with that said, let's take a look at how the mind looks at things. We're going to look at 4 different things today in terms of how the mind connects information. The first we're going to look at is cognition and identification, how our minds recognize things. The second thing we're going to look at is searching and seeing, or how we find things in the world around them to use them. After that point, we're going to look at mental expectations of actions and reactions. When we use a particular visual, how do we expect it to respond? And finally, we're going to look at how all of these factors package themselves together in everyday processes, or how we progress through different tasks through the interconnection of different visuals to achieve objectives. With that said, let's look at these 4 areas. First, we're going to look at, as I mentioned, is cognition and identification. And cognition is a fancy way for saying how the brain processes information. Now, while the brain is perhaps the greatest computer that ever existed, it still has limitations. And as it turns out, one of the most interesting limitations that affects how we use things and how we see things is input versus processing power. And that is, our 5 senses every second bring in more visual information than our brains can actually process. And because of that, our brain needs to make a choice, what to pay attention to and what to ignore, to figure out what it's actually looking at and how to use things based upon what it sees. That gives us our behavior, this restricted perception of visual input. We're going to look at how those dynamics affect what usability is in relation to visual design, and hopefully provide some insights that can help you with design processes. So with that said, the very first thing to look at is identification, or how our minds recognize visuals. So let's begin with identifying objects. Most of us recognize this particular figure as a cup. We've seen it before, but how did we learn this visual corresponds to a specific thing? Because not only do you see it and know what it is, I bet you reflexively know how to use it and what it does. How is that possible? It relates to how the brain shortcuts its data processing with visuals. First and foremost, when you were a small child learning language and learning what this was, you had no idea this object represented anything. Rather, a caregiver displayed the object for you and articulated a particular sound. Cup. This is a cup. And you learn to draw an association between this thing corresponds with this term. Now, that's still a lot of visual information to process, but a funny thing happens. Over time, you begin to see different versions of this same design. And as you begin to see these different versions in association with this same word, cup, you notice something. To recognize something as a cup, I don't need to look at every single visual characteristic of it. Rather, there are commonalities. And if I know what those minimal number of commonalities are, that's all that I need to look for to figure out, is something a cup or not? it's got a certain shape, it's got a certain height, it's got a certain width, it's got a handle on the side of it for the most part. Those minimal factors, those minimal visual cues, are all I need to see to know what this thing is. And what's interesting is that we begin to then limit visual information based upon that. And it lets us do two things. If I say the word, go find a cup, your mind pops open a picture of what you're looking for. And you're going to look for something that's got these same minimal characteristics to find the cup. But also, if I see a new object and look at it and I say, what is this? It's got these minimal visual characteristics. This is a cup. And this is the process by which we recognize things. This reductionist approach to what's the minimum visual information we need to identify what something is. Now, in terms of what we do as technical communicators, this becomes important because there are associations with design and use. Once I know what something is, this is a cup based upon what I see, we've also got corresponding associations for what are called attributes. That is, what does this thing do, or what is it known for? And for the vast majority of us, when we've seen a cup, we associate it with a specific use. It holds fluid, particularly hot fluid, which means the moment we recognize what a cup is, we know what it does and what it's used for. We don't need instruction on how to use it. Now, over time, we might see alternative uses of this same design. But the interesting part is, until we're exposed to these alternative uses, it becomes very difficult for us to figure out how to use this cup for something other than what we've learned in the past based upon previous experience. The reason this becomes important is it's the first cue in terms of how we design visuals to be usable. And we're looking at something called a prototype. That is the visualization we have for what something is. A prototype, this ideal visualization for what something is based upon minimum characteristics, allows us to do three key processes reflexively. The first is recognize. We know what the thing is. I see this object, I know it's a cup. The second thing is categorize. I know what this is, it's a cup, I know what it does. It belongs to the category of objects that hold fluids, so I know how to use it. The third thing, and the most complicated thing our mind then has to do, is called operationalize. Now that I know what this is and how it is used or what it does, I need to figure out how to use it in the specific context I find myself in. In the context of a restaurant, I recognize a cup, I know what it does. That means at some point in time, I'll have a fluid I can drink. So it's contextualizing recognized visual designs based upon where you are. Your mind needs to do this instantly to be able to use things effectively. And so these are the foundational building blocks of how the brain processes information. If we understand these factors, we can begin to create designs that are more usable by making them easier to recognize, easier to categorize, and then very easy to operationalize, regardless of context. For example, most of us have used a word processing program. And those word processing programs have icons that are designed to indicate specific features the program performs. Now, most of us have seen and are familiar with these icons. We know that the one on the left, the B, probably means bold, and the I probably means italicized font, and the U probably underlined text. We've got a rough idea because we've seen these specific visuals before, enough to know this is what I think they are, this is what I think they do, but how do I then use them? Well, operationalized, we're down to context. When those icons are contextualized or placed in an overall design where we've seen them before, we automatically know what to do with them, what they are, how to use them, what they'll do, and how to use them in this context. And so this is how, over time, we learn to recognize visuals and use them based upon how our brains process information. This idea of prototypes, visual models for what things look like that tell us what they are and how they are used so we can use them in a context. Now that's part of the puzzle, and those prototypes help us with something else related to use, and that's searching and seeing, or how we look for things. And to sort of illustrate how visual design and cognition affects searching or how we look for things, let's try a sample situation. You are driving in a strange city, a place you have never been before. you have no idea where you are. You don't know where you are going. You are overwhelmed because you are searching for anything, any kind of data input that can tell you, what should I do here? Where am I now? And it's a situation many of us have been in before. It's a case of true information overload. Since we don't know how to screen the information around us, we're taking it all in and can't process it. And then suddenly something catches our attention out of all this chaos, and we see it. It's the first thing we see. And often it's something like a stop sign. Now, why does that one particular visual pop in relation to everything else that's going on around it? Well, it turns out the reason that we suddenly can see it while we're searching for information is it's different. That is, its color and design are stark enough contrasts with the environment around it that our attention is immediately drawn toward it and we can see it amongst everything else. What this means is when the mind is overwhelmed or the mind doesn't know where you are, what context you are in, it tends to gravitate toward and lock onto things that contrast from their environment. That's what we see when we search for something in a completely unknown situation. So in new contexts, visual designs that are successful in orienting new users, new attendees, new visitors, are those that highly contrast from their background. Now the key here is contrast, not color. And that's important because you might hear individuals say, well, make sure you use the color red so that your image is noticeable. That only works if the red you're using contrasts from the regular background. Because stop signs work in a dim background where they stand out more. In a completely red background, if the environment is completely red, a red stop sign is not going to be easy to see because it doesn't contrast with its environment well. In that case, it's actually the drabber color that will catch attention more readily. Again, not because of the color, but because of the contrast with the environment. So in situations where we have no idea where we are, it's completely new, and we don't know what to look at first, our attention gravitates toward contrast. That which stands out the most from our environment is what we will look at and see among anything else. Now, this is in one kind of environment. In different kinds of environments, our minds will search differently. So if this is the case of unknown, where contrast works effectively, what happens when you're looking for something? And to illustrate this point, let's use another mental exercise. Let's imagine that our friend tells us, I'll meet you at the McDonald's downtown. Now, since we know where they're going to be, and we have a mental model for what a McDonald's looks like, a prototype for what McDonald's is, something pops to mind. We say, my friend is going to be at this place that's represented by this sign with the giant yellow M. Which means when I go into a completely unknown environment and I'm trying to figure out where my friend is, I'm not randomly looking for anything for the first thing that jumps out. Rather, I'm looking for a very specific thing, the thing that looks exactly like the McDonald's sign in my mind's eye. So if I ask you, where is my friend going to be? In the next picture, see how quickly you can find the location. Could you quickly find the McDonald's store where your friend would meet you? Chances are you could. And what's interesting is the speed with which you find it is surprising given the fact that it's not very greatly contrasted against its environment in comparison to the things on the other side of the street. On the left-hand side where there's an orange light pole and sort of a yellow sign a little further down the street, we can find the McDonald's sign quite quickly. Now, why is that? Why can we find it in this situation? And that's because we're using prototypes to drive our search behavior. We know what we are looking for versus we're in a completely unknown environment. If we know what we are looking for, we screen out all other visual stimulus except for that which represents our prototype, our mental model for where that thing should be or what that thing should look like. This is what helps me find a McDonald's on a crowded street and not be distracted by anything else. I look for that one specific thing. Now, this focused searching, this I'm looking for a specific thing, can cause some weird situations that some of us might have said before. Because many of us have probably been in the situation where a friend says, I'll meet you at the McDonald's. And if you look at the bottom image here, many of us would say, look, there's the McDonald's, I'll turn in here. And a surprising number of us will miss the stop sign that's right there. Now, the bright red stop sign, the contrast with the environment is something we should see. But a surprising number of us will not see it. We'll simply be looking for the McDonald's sign and ignore all other visual stimulus or input. When we're doing this guided or focused searching, that's how pronounced this blinding effect can be. If we know what we're looking for, we can screen out high contrast things to find the object we want to find. This is important in terms of design for a couple of reasons, in terms of how we build or configure designs that are usable based upon their visual attributes. And to illustrate this point, let's do a couple of tests real quick. I'm going to show you the interface for a mobile phone. And if you can, I want you to try to find the Call app and touch it as fast as you can. Ready? Find the Call app and touch it as fast as you can. On the count of 3. 1, 2, 3. How many people found it? Probably quite a few. And chances are you placed your finger on the second app from the right in the top column, the green phone. Now, why was it you were able to find it so quickly? Because in this case, you have a mental model for what Call Phone app looks like. And I'm willing to bet that for most of your prototype for app for Call Phone has a telephone receiver like this in it. And for this reason, you could find that app quickly because you knew what you were looking for. It was a guided focused search. If I know you're doing a guided focused search for something, I need to know what prototype you have for that thing and create my design to mirror it or mimic it. If I can do that, then you can find the visual information I need you to find because I'm meeting your expectations. Let's try something. Let's do a second test. In this case, I just want you to tap or touch the very first app that catches your attention. Just quickly, boom, put your finger on the screen. Ready? On the count of 3. 1, 2, 3, go. Now, chances are a surprisingly large number of y'all will have put your finger on one of the red apps that's here. It could be the red app of the square root sign with the equals under it. It could be the red app at the bottom right-hand corner with Wi-Fi. And for some people, it could be the red and green app in the upper right-hand corner. But a surprisingly large number of individuals will find or be drawn to that red app or that red design because since they don't have a specific thing they're looking for, their mind is looking for the most contrastive thing that will catch their attention. In this case, those colors are more contrastive against the black background, and most individuals tend to move for them. What's interesting is these are the exact same interface. Just in one case, you're doing a guided search where prototypes are guiding what you're looking for. In another case, you don't have any prototype to guide your searching or seeking at all. So in that case, it's contrast that guides how you look for things. These factors become very important in terms of how we create designs that individuals can use quickly based upon how well they can find the things they're looking for. So for example, we talked about the placement of icons for different features in Microsoft Word earlier. Now, most of us have become accustomed to using Microsoft Word. And for that reason, most of us have become accustomed to the different font change features that are associated with Microsoft Word. This indicates the B that's bold indicates bold, the slanted I indicates italics, the underlined U indicates underline, and we expect them to be in a certain place. We expect those features not to be in the bottom left or the bottom right corner, or even in the upper right corner. We expect them to be in the top of the page, up by the menu area, and to be more to the left than anything else. Now, the reason that's important is if I want to design another product, another word processing product, to compete with this one, I need to make sure my intended audience can use it reflexively because they can quickly find and identify different features based upon their design and use them reflexively because they've seen features like this in the past and know how to use them. Which is why when you look at a program like OpenOffice, it's got a very similar design to Microsoft Word, its word processing program. Now that similarity, the fact that it uses that bold B for bold, that slanted I, even though in this case it's a lowercase I for italics, that underlined U for U, is not accidental. It's attempting to mirror previous expectations of what people are searching for. I need to bold this text, I'm searching for this icon. And once I can search it and find it, I know how to use it. And most of us could look at this and know how to use it without realizing we're in a different program. And so this is an example of how the more we know what users are looking for in visual design, and the more we can mirror that design in a marketplace where people are already accustomed to designs, we can make products that are more usable based upon expectations. So what does all of this mean in a nutshell? Well, what we're talking about is contrast or conformity of search. If the search involves a new product, something no one has ever seen before, something no one has ever used before, it's brand new in the features it offers, then contrast is the central thing we're going to use for design, because contrast helps our user find things quickly and easily. What we'll do in that case is we want to reduce competing features. That means the number of different visual designs on the item needs to be kept to a minimum, because the user will be overloaded very quickly if they've got to choose between too many different things they've never seen before. So options need to be kept to a minimal. The next thing we need to do is to make key features that we want users to use first or want users to use regularly to be high contrast so that they can find them very quickly. For example, a button that says click here to start or start here will most likely want to be highly contrasted against the background, say bright red against a white background, so it quickly attracts the user's attention based on contrast. And the final thing we want to do is to position that item in a place where it's very readily findable. If I position that Start Here red button in the lower right-hand corner of a page, chances are it'll take my user a few moments to find it. But if I position that red button in the dead center of a completely white page and it says Start Here, that's where my audience will focus on because it draws their line of vision. So positioning items in a way that they're readily viewable, making them high contrast, and preventing them from competing with many other visual features can help make visual designs more usable with new things. With product updates, this becomes interesting because now we move from contrast to conformity. And for many of us, we've lived through a software update or some kind of update where the company has, for some reason or other, changed a few key visual features in the design of an interface. They might have moved where different menu items are, or changed the designs of icons that we use to perform tasks. But when they do so, we are really hard-pressed to be able to use that product effectively again, because it violates our expectations. Rather, what the organization needs to do is seek conformity. We need to make new things look like or resemble the visual design of old things, so our users can find them very quickly and use them reflexively and easily. In this case, for updated products, we're going to stick with something called parallel design. To use the examples of the icons for bold, italics, and underline earlier from Microsoft Word, if we're going to update Word, we're going to keep those icons the same because we want users to be able to find them again easily because they know what they're looking for. It's a guided search. They're using their prototype for this icon to find it. Not only do we want to design it the same way, we want to place it in a parallel position. And that is, if I expected this icon to be in the upper left-hand corner in the previous version of the software, then that same icon needs to be in the upper left-hand corner of the updated software also, because I need to know where to look for it, as that's part of the visual expectation I have for those visual cues. And again, all of these are driven by prototypes, previous experience, seeing something, identifying visual features of a certain kind in a certain place. Now, things can get a bit sticky if you've got a new product, but you're competing with a market that's already got other products in it. And this is where we see the kind of comparison we saw earlier between Microsoft Word and OpenOffice word processing programs. And the idea in this case is because there's already something out there individuals are familiar with using, they've become habituated. They've got prototypes that tell them what they're going to look for when they use this kind of product. It becomes my job or my task to figure out what are those habituated features they look for. What kinds of things do they expect this product to do? What kind of visual designs do they associate with the features they use to perform that task? And where are those features located on an interface? I need to create parallel designs of my icons so individuals can find the features effectively. And I need to use parallel placement of them if possible, relatively, so individuals can again find them based upon where they expect them to be. But again, we're tapping this concept of prototypes, which drives how individuals search for things. If I know what I'm looking for, I've got a very specific prototype I use to guide my search, and you need to meet it for me to find it. If it's a completely new thing, then the more contrast, the better to locate things. This brings us to a key factor in terms of what visuals should do in a design. And we're looking at action and reaction. And in this case, it turns out that we're playing with a concept that's based upon how humans have evolved communication patterns over the past 2 million years or so. And for most of history, human communication has been direct face-to-face interaction. And it's been highly visual in nature. And so what would often happen, and in fact, we do this in our everyday lives, we approach somebody and want to ask them something. But before we say a word, we create a visual mental model of how we think they're going to respond to what we're going to say. In fact, we'll create multiple visual models to assess how they might respond to things. If I need to ask for $20 and I ask for it this way, I think that the person I'm speaking to, say my brother, might respond in this fashion. If I say it this way, then the mental model I have says my brother might respond in this fashion. And if I ask for $20 in this way, he might respond in this fashion. Now, what's key to this is these mental models I'm creating for how my brother will respond to my request are visual. They're what his face will do, what his body will do, the visual reaction he will have to what I say. I use this mental model to say, this is the best choice. I'm going to say this and I expect this result. And so I say my piece. And then I wait. And we've all done this before. We wait for some sort of feedback, some sort of cue that indicates, has the person understood what we've asked for or not? Now, if the visual information we get is not indicative of that, then we have problems. And it turns out we look for two very specific things when we interact with human beings for feedback. The first are faces. We look at someone's face to figure out what was their reaction to what I just said. Is there a specific response I can tell happened? The other thing we look at is their body language, their body posture. How did they position themselves and what did their face say in response to what I said? We very heavily use that visual information, those visual feedback cues, to figure out if they understood what we said and if they agree with or wish to act upon what we've requested of them. Now, if it turns out they didn't visually respond or provide the feedback cues we expected, we scrap our initial mental model and we create a new one. Okay, this time I'm going to try it this way, and I expect my brother to react visually this way to indicate he's understood and approved. Again, I say my piece, the revised message, and look for visual feedback cues to indicate, did he understand? If I don't get the cues I expect, I scrap the mental model and I try a new one. And we continue this process of create mental model, attempt communication, wait for response, read visual feedback, use visual feedback to determine comprehension. This continues on and on until I get a match. That is, until the visual response my brother gives me to my request is what I expected, and his overall response is what I expected. At that point, I'll stop because I know I've got comprehension. Alternatively, I'll give up and walk away because I think comprehension can't be achieved. The reason this is important is it's an action and reaction system. It's kind of like physics. For every action, there's an equal and opposite reaction. Every time I communicate, I wait for the reaction to what I've just said, the action I performed, to figure out, is everything okay? What's interesting about that is that same mental modeling we use for human interactions is exactly what we use when we interact with a technology or a visual design. So, for example, I've got to call my father on my cell phone. What I do before anything else is I create a mental model. Okay, I'm going to use my cell phone to call my father. I think I need to find an app that looks like this. And to use the app, I touch it twice, and this screen should pop up that allows me to dial my father. Literally, there's a visual model for what I expect the technology to do and how I expect to use it. And as with speaking to another human being, I use that visual model to guide my actions, and I perform the process. And I wait for some sort of visual feedback from the phone, for the phone to do something of a visual nature that indicates that my request was received by the technology and the technology processed it accordingly. If I don't get that feedback, the message that says calling now, or the message that says call could not be completed, then I've got to scrap the initial model I have and come up with another one. Okay, take two. I think if I use the phone this way, new visual model, new attempt to try, new waiting for visual cue feedback, what do I get? And this process, as with human communication, continues over and over until I get the technology to respond the way I expect it to, the visual prompts to show up as I expect, or I give up. So what does this mean in terms of design? It means that designs must be highly interactive, and they've got to be visual to a very high level in many cases for individuals who are sighted, so that they can use technologies effectively based upon this reflex that we have for using visuals to interact with things for communication purposes. So if I say perform task, like a set of user instructions, well then once that task is completed, I also need some sort of visual signal that helps me recognize, oh, this is done. So it's done, here's the visual prompt, the visual feedback that says this is completed. But it's got to be more than that, because once one part of a process is completed, I need some sort of visual cue that says go on to the next process. So again, in addition to text, I'm looking for, is there another visual cue that prompts me move on to the next step, so that I recognize, oh, there's more that needs to be done. And this process of response feedback in terms of this is done, here's the visual that indicates completion or success, move on, this goes on till the very end. And even at the very end, we need some sort of visual, some sort of cue that tells us, okay, you're now done, you can stop now. But we need both. We need, that verbal piece is good, but the visual cues are highly important because they're what we're hardwired to look for in many cases to figure out a process is proceeding accordingly. So what does this mean in terms of design? This action-reaction factor touches upon something called the attention comprehension gap. And that's the idea that for something to be usable, for a visual design to be usable, it's got to do two things instantly. Number one, it's got to catch our attention without question. We've got to be able to see it so that we know something has happened. And the second thing we have to be able to do is understand it. It's caught my attention. Now, what is it trying to tell me? What do I need to do now based upon the fact you have my attention? And so we're looking at visual designs that need to have three key factors or address three key areas to be cognitively effective based upon how our minds process information. And those three factors are, number one, that design has got to gain our attention. Look, congratulations, you've completed this step effectively. Yay, move on. Some sort of visual that indicates that. In this case, the thumbs up icon that's there. But whatever visual you use has also got to be readily understood. Now, for many of us, the thumbs up icon is associated with success. It's a good thing because we've become habituated to that. If we'd never seen a thumbs up icon before, we need to provide text that tells the user what that means. And this is where you get task is complete, thumbs up. But the idea is, in this case, the visual cue catches our attention. And if the visual itself is not enough to help understand, the text supplements it to let the user know, oh, this is what that visual means, this is what's happening. But most important of all, we can't assume that someone knows to go on to the next step in a process, especially if they've never done it before. So we need to provide visual cues that also indicate, good, you've completed this step, now move on to the next one. And again, it's got to be a visual cue that catches attention and says, do this now, and here is why. And for many of us, it's something that we see in things like error messages. Error messages have a visual design that catches our attention. In this case, contrast. It's red against a white background. We know something is wrong because that white X for many of us is habituated to say something is up, something is not correct. And then there's text that explains to us, well, here's what might have happened. Here's what you need to do next. So not only do we have comprehension, I've got your attention, something went wrong. Now you need to know this, and here's how you should probably proceed. But we need these three elements of a visual design to make it effective for use purposes. Final part. Now, all of these visual factors don't exist in isolation. Rather, whenever we perform a process, it's in a progression. Quite often, we do many things at once in a series to achieve an overall objective. And each of those things we do in the series often has an associated visual design. For example, if I want to log on to an interface to get into a system, I've got the initial screen I often have to go to, the login screen I go to, an initial page I get after login that orients me to the specific page I'm trying to get to through that overall system. Each step in this progression is essential to get to my final objective. Getting into this one final system, this one final online class I need to use. But each step brings with it a corresponding visual environment I need to design for to meet these concepts of prototypes and recognition, to meet these concepts of identification and use, of visual and verbal constructs in terms of action and reaction. I need to build them all together at each point in this overall system to create a visual flow of communication or interconnect them. And so what we're talking about here is what's called 4D design. That is 3D. 3 dimensions are the dimensions of physical space. 4D is time. And so what we need to consider with progression and interconnection, or if you will, 4D design, is how things will change over time as people use them. From step 1 to step 2, as time progresses in a process, what visual changes will take place? And while they be complicated, they can be mapped. And so the key here is before you begin any visual design on any part of a product, you need to figure out what the overall path or flow of that product will be, which many of us do. But it's something that can be forgotten at times. So what we have to do is map visual changes. As the user is going through this system, where will the visuals change? Where will different icons appear? Will different prompts appear? Will different menus appear? I need to know where they appear so I know how to structure them so the user can find them. This mapping process involves identifying 4 key factors or asking 4 key questions. The first is, in each step of the process, what should the visuals look like so that the user can recognize them instantly and know what they are and what they do? So first thing, what should the visuals at this step look like? Second thing, contextualization of meaning. Okay, in this context, on this particular screen, what does that icon mean? It means log in, but what does it do when someone clicks on it? And the reason that what does it do is important connects us to the next part, which is recognizing and indicating action. If I click on that logo, it indicates enter password here. So how do I let the user know that they've successfully completed the process? There needs to be a visual change that indicates successful completion or process done incorrectly. Please try this, or please try again. If they don't have this visual cue that indicates success or failure, they'll either get frustrated and give up, or they'll keep trying the same thing over and over and over again because they think something's not registered in the system. This brings us to the final part, which is orientation in new context, and that is when you move from one visual system, one part of an interface, to another, there's going to be a visual change that occurs. How do you prepare the user for that visual change so when they land on a new page, they're automatically oriented to where they are and what they need to do there based upon the visuals that are there? And the idea is for each step in a process where a visual change occurs, to use the previous example of working through an interface, for each screen that the user has to go through, what are the visual features that are present? How will the individual use them and find them? What changes will indicate someone has used them correctly? And what visual things should they expect to encounter on a new screen? We need to map these factors for each of the visual changes in a process. That's the mapping part. And at a breakdown level, what it kind of looks like is the following. We've got to give them icons, number one, that draw their attention and that ideally they recognize. But if they don't recognize them, we've got to provide some sort of verbiage that tells the user what they do. In this case, we've got a program the user's never used before. We've got to get them to start the program and use it to progress through a series. The high contrast color catches attention. The text indicates what they need to do. There's no competing image on the page. I pretty much got their attention. Now the key part is once they click on that icon, a visual change has to take place. Maybe it lights up. Maybe it changes to a different kind of image, but some sort of change has got to take place that indicates to the user, oh, it recognized my activity. There's been a reaction to the action I performed. For each step in this process, this needs to persist. There's a new visual that indicates next step. Ideally, that new visual indicates was the process completed or not. In this case, we click on the red cherry icon to start a process. That red cherry turns into a different visual image that indicates the process. This step of the process is completed. Congratulations. This new visual indicates completion. By the way, here's the next thing you need to do. And notice you're leading someone through a process with design because of a visual change. This continues throughout each step of the process. New visual, some sort of explanation that lets the individual know what to do with it. Once it's clicked or accessed, there's some sort of visual change that needs to take place to let the user know what's happening, all the way till the very end. And at the very end, some sort of different visual needs to appear to indicate the process has completed. Here is what will happen to show that it's done. In this case, you might receive an email showing that you've completed the registration process. But you need to map out where the changes in the system take place so you can graft corresponding prototypical visual changes that individuals can recognize and use effectively. And when you're doing this, you need to consider 2 factors. You need to consider what's the visual response if they click on something and do it correctly. This is what correct looks like. And what's the visual response for error? You didn't do this correctly. Here's a potential problem. which means when you map out these visual design factors, you need to have both ready. The visual change for correct and the visual change for incorrect to help guide the user through the process based on how their minds process visual information. That was a lot of information in very quick order, but thank you all for your time and patience. I hope this was helpful. And now I'd like to open the floor up to questions. Thank you.
Excellent. That was great. I'm glad we recorded because, there's a lot of things here that I've heard or seen before, but not put quite this clearly. Thanks for doing this. What a great session.
Thank you.
Now it's time to type in those questions if you haven't already. And while you do, here's a look at what's coming up. The TC Dojo Mastermind Groups are monthly driven member discussion groups where attendees present their specific challenges to a group of their peers in a confidential, supportive environment. A mastermind is a collaborative environment where everyone lends their experience to each other. They can get feedback and advice about topics on their mind in real time from others who've been in their shoes. It's been amazing to participate in and a lot of fun too. We have 3 going on right now. One is everything TechCom, data, topic-based authoring, the specifics of cross-references or graphics. The other 2 are product-focused on Windchill for IT and ArborText users. These sessions are not free. They're a way to guarantee commitment between the participants. You can sign up at the TC Dojo website at mastermind.tcdojo.org. We know sometimes magic is just having the time to collaborate with someone who's been where you are. Next time in the TC Dojo, it'll be me. I'm going to talk about style guides. It's a shortened version of my STC Summit presentation, which was standing room only in May. If you're interested in creating or working in style guides, be sure to sign up. Let's get to the questions. Back on the cup prototype example you had, the slide with the cups.
Yes, ma'am.
Interesting. I would call that a mug. So vocabulary is also in play here?
Very much so. We probably would call it a cup until someone teaches us mug, or vice versa. It just depends on how you're introduced to the visual, kind of brands it in your mind in terms of what it is.
Excellent.
And just for the these things are plastic. That is, they're over time, as you learn different iterations of a thing or different ways of looking at the same thing, you'll change the prototype you have. Which is why the prototype we all had for car when we were growing up has evolved over time to include now, self-driving cars. So they do evolve, but they require exposure for them to happen. Otherwise, we default to what we knew before.
I think you could probably do a whole session on prototypes and how they grow and change in the specifics of it.
Oh, that could be cool. Yeah.
All right. Let's see what else. The button in the upper left, next update should also be in the upper left. Does visual cognition intersect with muscle memory?
Yes, it can. The thing is, ideally visual cognition is trying to end run deep thinking, if you will. So you see it, you do, because there's an instinctive reaction to how to respond to something. So yeah, it will bypass to go to muscle memory as often as it possibly can. And this is why for many of us, we can drive a route without thinking about it, because at a very superficial level, we see things and our muscles know how to respond due to habituation over time. But that's why we can make horrible mistakes because we're not paying attention because our muscles take over when we don't actually catch certain kinds of data, which is how we can get lost in our hometown whenever there are detours. So yeah, muscle memory is huge.
Cool. Here's another one. It sounds like this makes controlling vocabulary and taxonomy super important.
Yes, it can, particularly in intercultural situations. And by intercultural, I don't just mean say national or ethnic cultures, but also professional cultures. What's statistical significance to a scientist versus an engineer versus a psychologist versus a marketer? So all terms have come with them kind of loaded backgrounds. And the more you understand how different individuals use vocabulary, particularly what they default to in terms of what does it look like and what does it mean, or is it used for, or how is it used, are huge in terms of thinking about recognizing what something is. So yeah, great observation.
Cool. All right, here's one. As technology enables other ways to interact with products, for example, VR, haptic, tactile, as well as interfaces augmented by AI, what's the future of visual and UI design?
Great question. This is just me kind of speaking off the cuff, but I think what you'll see happen with visual VR and AI is what's happened with conventional design, and that is things begin with here's how it looked before or in the original context. With the new technology, we need to parallel that visual design so people can recognize this new thing in this new context and know what it is. Once they're comfortable with it, we can begin to evolve the change of it slightly so that it begins to look different. And if we just change it slightly over time, a bit more, a bit more, a bit more, we can get to something completely unrecognizable in, say, a generation. Classic example, and I'll shut up after this. I mentioned in one of my examples, find the call phone icon. Now, I'm willing to bet about 90% of us has not used like a traditional landline receiver for at least a year. So how come we're defaulting to this is what a telephone should look like? It's because that's what we grew up with. And that's what we look for when we think of phone. And the key question becomes, since now we're habituated to something that looks like what I would call a pocket calculator, it's probably only a matter of time before that icon begins to shift to something that looks more like that more everyday, commonplace looking phone or mobile phone. So yeah, I think what you'll see with AI and VR is they'll begin slowly. This is what it looks like in the quote unquote real world. Now let's modify it slightly. And they'll keep making these modifications until eventually the original design is obsolete. And just think of it this way. Self-driving cars still have steering wheels and they still have driver's side everything. That's a comfort factor, right? Because most of us are going to be a little bit hesitant to get in a car that doesn't have any of this apparatus in it. But how long is it before we become so comfortable in an automated car that we can do away with that technology altogether? We no longer expect a steering wheel to be there. So those things will happen as we become more habitual. My prediction. And so let's see what happens.
Wow, very cool. I had one other one. Reacting to faces. You're talking about one of the first things that we do. VMware did a presentation several years ago, I want to say almost 10, that they noticed if their teaching videos online had a human face as well as the thing they were describing, they had a lot more attentiveness, and people learned it better.
Yep. It's we as a species, we have habituated ourselves to look at facial expressions if we're sighted. And it's really key to us because think about it. The primary mode of communication for most of our evolutionary history has been visual, because language is a relatively recent evolutionary development and cognitive one. So we're very hardwired to see faces, find faces, read faces. And when you think about it, we've all been in a situation where we're in a crowded space and we know exactly who is looking at us because we know we've been that habituated. We know people's feelings we've never met before by their faces. And this is also one of the reasons I think we see pareidoia, seeing faces and things. We look for faces to cue us on things. So yeah.
Cool. And these kinds of patterns, these prototypes, they're developing all the time.
They begin at a very early age as we're taught to recognize things. And they continue to evolve as we see new things and are told what they are and shown how they're used.
Oh, here's one. Are redundant icons in a new UI useful? These icons performing the same task?
It's going to, great question. It's going to depend on two things. The first is, what is the intended audience accustomed to? If they've used this kind of interface before, this kind of technology before, and they expect that redundancy to be built in, then they're going to look for it for the most part, because it's part of their prototype for what this interface should look like. If it's completely new to them, then you actually want to cut down on the number of visual factors that could be distractions, because the more visual information they have to sift through, whether it's redundant or not, the easier it is to overwhelm and confuse them. So it could be actually better to keep the number of icons to a minimum, but make each starker in terms of its visual contrast. Make one bright red, one bright yellow, one bright orange, with either an icon or a bit of text that indicates what it is. Could be a better way to help individuals find it. Again, my 2 cents.
We got one that says, great job.
Thanks.
And I've got one for you. Have you seen Google Quick Draw?
I have not. Tell me about it.
It asks you to draw a cup, and then it tries to guess what you're drawing.
Nice.
And it's very minimal.
It's
playing fascinating.
It's playing with artificial intelligence, how the same process. Yeah, exactly. We feed these prototypes into a system. If it looks like this, this is what it is. As cheesy as it sounds, if you're as old as I am, you remember this Arnold Schwarzenegger movie called The Terminator?
Absolutely.
And basically, it was based upon the notion of this robot moves through our world and recognizes things by looking at their basic minimal visual characteristics and saying, this is a dog, this is a house, this is a car. That's pretty much how we're kind of working this in artificial intelligence. What are the minimal visual characteristics we need to recognize something?
Cool. All right, and Nessie, great job from the audience. And I can't help but agree. It's awesome. Thanks for doing this. We're so glad that you come every time. It's always good.
My pleasure. Thank you all for the opportunity to chat. My email is there. I'm happy to follow up and answer questions at any point in time and share slides or chat with anybody. Liz, thank you so much for this opportunity. I really appreciate it.
It's totally my pleasure. Thanks for coming to the Single Sourcing Solutions TC Dojo, where it's all about you, what you want to learn. You should always attend a webinar live because you can't ask questions of a video. Subscribe to our TC Dojo mailing list at join.tcdojo.org and never miss another. Every month, we go out and find experts willing to share their expertise based on your votes in the TC Dojo survey. Why should we tell you what to learn? You should tell us. So be sure to vote at survey.tcdojo.org. The TC Dojo is our pleasure to host. As always, if you need more personal help, we're here to take you from the basics to mastery. See you next time.